So we've talked a lot about optimization this morning, and by the way, the reality is that some of these are the most computationally intense and complex problems to solve in the world. Now, to overcome this, SAS R&D has been innovating with quantum AI. We are combining quantum computing with traditional AI to process large, complicated data sets and take those times down from months down to minutes. Let's take a look at how we're doing this with Procter & Gamble, a leading consumer goods company. Please welcome to the stage Krista Comstock, Director of Digital Innovation at Procter & Gamble. Krista, it is so great to see you. How are you doing?
Doing great, thank you.
I'm going to get in my right spot here.
Exactly.
All right, so first of all, our partnership goes way back. I mean, there's some great history here, and we're really proud of this. So just to give you context, our partnership goes back to 1980. So we've been doing business together for 45 years. I mean, that's amazing, right? So, and I want to call out some key milestones in this. In the early 2000s is when we started to work on the optimization problems with you all. And then recently, in 22, we actually migrated P&G to SAS Viya to modernize all of your AI capabilities. And I feel like all of this is that work together, the trust we've built together, has set us up to explore quantum computing at this very moment. Can you talk about that?
Sure. So while I was not at P&G when we started in the 80s, I absolutely remember when I started in the late 90s hearing about our collaborations with SAS, and then more specifically, as you said, in the early 2000s when we started doing the cost and performance optimization work, I actually was responsible for some of the data systems that were coming into that work, and so hearing about that then. And that has really paid off for us. And I think, as you said, that really did set us up now to be looking at quantum together, because it gave us the foundation to know that SAS understood the kind of problems that we were interested in at P&G, and gave us the confidence that we could make some good progress and have some insights from this work.
I think it's a great way of saying that, like, if the two organizations, if they know each other well, you can really be very focused on the type of problem you want to solve with a high propensity to get an ROI. So with that, we really wanted to make sure we worked with you all on optimization, because we knew this is where quantum could start to shine. So can you give us some insight into some of the problems we were looking at here, the problem we selected, I should say? Absolutely.
One of the things is I've worked across several of the modeling disciplines at P&G is our problems are never easy. Yeah. And it's one of those things where, and I sometimes think that, software vendors as yourselves are probably a little bit like, oh no, what are they going to be asking us now?
No, that's our moment. That's our moment to shine.
And so one of those pieces about our problems is there's typically something about the scale that is unique and different from others, in other industries that you might be working with. So in this case, we manufacture a lot of different product variants on a few production lines with rules that regard what can and cannot mix or be used on the same equipment. To make this real for those in the audience, is go down one of the aisles at your local grocery store and look at all the variations of just a Pantene shampoo, but there's a lot of different variations, or Tide laundry detergent, similarly a lot of variants there. And so what we wanted to look at was what is the optimal assignment of those products in these few number of tanks to really ensure that certain products never mix. The scale here is immense, and so therefore we thought it could be a good fit for quantum.
Well, Krista, before you go further into this, I do want to take a moment here to share a cooking analogy to help us all follow along, because quantum's pretty complicated, and I think this will help us all participate in this process. So, imagine you have a 5-burner stove with only 5 pots and pans to use. You need to make 10 dishes using dozens of ingredients, and you have to reuse some of these pots without cleaning them. Now, for those of you in the South, this means you're going to get some beans in your rice, right? But my sons are allergic, and for those with food allergies, we have to be careful about cross-contamination. So now let's translate this into the business problem with P&G. At P&G, you have a handful of mixing tanks with hundreds of products and ingredients, and the scale of this problem is shocking.
Absolutely.
I'll wait to reveal this.
And I am so disappointed I didn't come up with the analogy, because I like analogies. But it's one of those things where, so we're looking at 100+ products in 5 tanks. So when you start to think about the scale of that, as you reveal it, we're talking about the 10 to the 114th power, which It's not small considering it's larger than the number of atoms in the universe.
That's also pretty much what's on my honey-do list right now, I'm pretty sure my wife would say.
Yeah, so we need to get you out of there to go work on it. Exactly. So using traditional solvers, the compute time and resources needed really grows exponentially with that problem side, which led us to the quantum approach.
So that is a massive number of combinations that really most of us can't even comprehend, first of all. But as we conducted research together, can you describe to the audience kind of the approaches and associated results? Because this is really where we really see how unique the strategy is and how the impact it can make.
So we looked at it in the end 3 different ways. The first way is using traditional solvers and using the traditional capabilities within SAS VIA. And in this case, the quality is there. The feasibility of the result is there, but speed, it took about 6 hours to get to the optimal.
I don't want to say, too, our solvers are pretty awesome, too. We did some good analysis on that, just even the traditional ones alone. But 6 hours is a long time still.
It is quite a long time. And so, therefore, looking at quantum, starting with a smaller problem, it's one of those things where you could really see that benefit. But even as we started getting up into the scale, this started to struggle a bit. Results in 2 minutes, great. But in terms of the results, it's one of those things where we're starting to see some suboptimal results. And so that led us to the third, to really see how could we bring this together, which is hybrid. So in that case, starting with the quantum, basically getting to that close but suboptimal.
A subset of solutions that leads into the traditional.
Exactly. And then using the more traditional solver to really get to that global optimal. And in this case, was able to get results in 12 minutes. So we went from 6 hours to 12 minutes, 97% reduction in time.
That's amazing. And by the way, there are a lot of people that say quantum is 10 years from now. No, quantum's right here, right now, and we're doing it. And I really, really am excited about what we can do. And I'm excited for what you all might come to us and say, how can we use quantum to help solve your problems? So now, talk to us about what are some key takeaways from the results on this?
The first ones are pretty obvious. It's about productivity and performance. Hybrid can really give us the best of both worlds in terms of giving us the speed and as well as the quality of solution all in one. The second is really the accelerated learning. As you can go through this, more quickly, you start to really be able to get insights quickly, as well as rethinking, it caused us to rethink a little bit of the problem formulations. And explore some new ways to transforming the data.
And I think when we talked about this, problem selection is key, right? Navigating quantum is understanding, are you going to get the, how do you know which problem will give you the ROI in complexity? That's important. So now moving forward, I know you all see some more opportunities with quantum. What are you thinking about there?
It's one of those things where, and some of this kind of goes back to the previous topic even, in that digital twin space. Where is it that we could really use both the accuracy and the efficiency in more real-time simulation? And for us, we could see that perhaps in looking at our production schedules and resource allocation, improving overall supply chain resiliency and efficiency. One of the things about PNG is that our demand can really change very dramatically, daily, depending on what's going on with the retail customers or what's happening in social media, a TikTok trend or something like that.
Oh yeah.
And so, how can we respond to that in near real time, can really drive both innovation as well as efficiency across our manufacturing operations.
Well, first of all, again, want to congratulate both the PNG and the SAS teams for making this incredible breakthrough with quantum. That's amazing. A little round of applause, please, on that. And I want to thank you for your continued partnership, and I'm looking forward to another 45 years of partnership with PNG and really the continued innovation work both organizations are going to do. Thank you so much, Krista.
Absolutely.
A great one.
Thanks, Brent.